Hi everyone and welcome back. Today we are going to solve the lead code problem equal sum grid partition number 1. We are given an m by n matrix grid of positive integers and our task is return true if we can make either one horizontal or vertical cut on the grid such that each of the two resulting sections formed by the cut is non-empty and the sum of the elements in both sections is equal. Otherwise, we return false. So, the question is, can we split this grid into two parts which is exactly equal in sum with just one cut? The problem is that most people try brute force and completely overcomplicated it. But the real trick is we don't need to try every cut. We just need to think in prefix sum. So to solve this problem, first we will need to do these steps. First, calculate the total sum of all the elements of the grid. So this is sum of all elements in the grid. If it's odd, in this case, we immediately return false because we can't split an odd number into two equal integers. Then we simulate the cutting the grid row by row. So, for example, if I have a grid that looks like this one, and here we have row 1, row 2, and row 3. Then we keep adding row sum into a variable. Let's call it current sum. First, we add to it the sum of the first row, and then for each row, we check if the current sum equal, or we can write it like if the current sum multiplied by 2 equal our total variable, this means that we reach a row that can simulate the cut. And we have now two parts that are exactly equal. If not, we keep adding the second row and so on and so forth until we reach a cut or this condition either is true or we can break early by checking if the current sum multiplied by 2 is greater than the total. That means that we have to stop at this case. We have to stop immediately because we already passed the halfway point. And then we repeat the same for the same idea for the columns. We scan column by column, adding the sum of each column to our current sum, and also check if the current sum multiplied by 2 equal total or not. So let's implement this idea. So first, let's define the grid size by defining m equal the grid size and n equal the grid of u size. Then we define the variable total initially to 0 that will hold the total sum of the grid. So for two row in the grid, for each row in the grid, and for for each value in the row we will append this value to the sum, to the total. And here we have to check if the total must 2, then we return false. Here, check that total is odd number. After that, we check the horizontal cut. By iterating over the element of the grid, height less than 10 and plus I. And here I define a variable, let's call it current or row sum, initially equal to 0, and then looping over the columns. And adding the current element to the row sum. And then append the row sum to our variable, let's call it current. So we have to define our current variable here. So far our current variable is initially to 0. This variable will hold the sum of each row. So the row sum will hold the sum of the current row, and then we append that sum to the current. And after that, we do our checks. If current multiplied by 2 equal total, then we return true. And also we need to add the check that if our current multiplied by 2 is greater than the total, at this point we will break, not returning false, because we have to check the horizontal, the vertical cuts, and then we check the vertical cuts by doing the same. First, we need to reset our current to 0, and then for and j equals 0 and j is less than n and plus j. It is almost the same as the horizontal cut. For n I equals 0, I less than n and plus I. And we need here to define our column sum and set it to 0. And at that point, we are appending each value in the column to the column sum. And again, we append the column sum to our current variable and do exactly the same conditions here. And if none of the for loop return true, so here that we couldn't find a valid split, so we will return false. Let's run it to make sure that no syntax error. Yes, and let's submit it. So this is solution for today's problem. As you can see, no extra arrays, no complicated logic, just a clean prefix accumulation. And this reduces the space complexity to O of 1, so space complexity is constant, while we're still keeping the time complexity to be O of n multiplied by n, which is the size of the grid. So that's all for today. If you want more clean tricks like this, please subscribe to the channel and uh, see you in next video. Thanks for watching. Bye.